One.
I am Bill.
And I'm David.
Our science experiment is the Gauss rifle.
The Gauss rifle essentially is a magnetically powered gun. This fires magnet and ball bearings at a high rate of fire, as like this. So you push this ball forward, and it will fire. And the last ball will move at high speeds from the Gauss rifle.
Our question is, does the shorter distance between the magnets result in more distance or vice versa? And our hypothesis is that the shorter the distance between the magnets, the farther the ball will go because less energy is lost between magnets, so the ball will go faster, resulting in longer distance.
Okay. The testing procedure is, because we cannot push the ball, because we do not know how much force we're pushing the ball with, we put the ball here. This place is controlled by one single pulley. When you pull this out, pull the pole out of this thing, the ball will roll down because of gravity and be attracted to this magnet. The ball will then hit this magnet and then cause a chain reaction, causing this ball to release from the magnet and hit this magnet, causing a chain reaction all the way when it gets here, where it fires off the rifle in very high speeds.
Higher than when it previously went, from here to here. Our materials include 4 magnets, 13 metal ball bearings, tape, a track which the ball runs on, and knives/scissors to cut excessive tape.
Alright, to build the Gauss rifle, first you put the track down, and then you first tape 4 magnets the desired length apart. And then, after you tape down the 4 balls, after you tape down the 4 magnets, take the 3 balls and put them right in front of each, put 3 balls right in front of each magnet. And then take the last ball, the 13th ball, and place it on your spoke, or whatever, the end of the runway. Make sure the ball is on the side of the magnet that has no balls facing it. And then, to operate the Gauss rifle, all you do is pull and watch the Gauss rifle fire. So these are our results. This first one says a test for 3 inches between each of the magnets. This resulted in this type of result. When we did 3.5 inches between each of the magnets, we noticed that we had one outlier, but we decided to keep it because it was still part of our test. But during the 4th inch, it averaged out much more evenly. When we look at our average results, for 3 inches between each magnet, it went about 45 inches between. For 3.5 inches between each magnet, it went almost 50. But for 4 inches between each magnet, it went around 81 inches. So we conclude that
our hypothesis had been wrong, and that the farther distance between 2 magnets meant for farther distance fired.
Okay, so this is our photo album. This first picture is firing a test version of the Gauss rifle. The second one is our second version of the Gauss rifle. This third one is testing that our Gauss rifle actually worked. This one was just a Gauss rifle that we have found on the internet. It looks pretty cool, don't you think? And this last note one is our test results. We recorded it all on one note card.